Well, it's great to be here again. Couldn't make it last year, but very excited to be here. I brought Razvinator here with single-handedly. And today we want to walk you on onto our journey. Hey, Dan. On AI transcripts in Jitsi Meet. Quick show of hands, who is familiar with Jitsi? Yeah. Okay, a bunch of hands. I'm going to still do a quick intro because I like to frame how we approach transcriptions. We've heard about transcriptions in a couple of presentations already, and I do think that there is a certain element to the context, not in the AI way of context, but in how we're using them. So Jitsi Meet is a set of open source projects. So it's a pretty comprehensive platform. You can run the individual components of all of them together to create like a full-blown video conferencing platform. We've got APIs and SDKs in case you don't necessarily want to build out the platform. I'd rather integrate with it. And it is an open source community. Jitsi started out over 20 years ago in a sort of different fashion, and it has evolved to what it is today over time. And over this time, we have counted a few notable people using our software over the years. And yeah, we're pretty proud of where we arrived today. One of the latest sort of products we launched as a sort of a next step for Jitsi as well, because many people wanted that, is a platform as a service kind of offering. We call it JAS, or Jitsi as a service. And it's basically a hosted Jitsi that we run. And all of the features we're going to talk about today apply to a hosted version or a self-hosted version. But there's many customers that don't want to run their own infrastructure. And because we've got APIs at the low level and at the high level, they can build their own video experiences. For instance, one such customer is Brave. So Brave Talk is built on Jitsi, heavily customized, and they run on top of JAS. We're also going to show how a little bit, we're going to mention how they integrate also with the transcription side. And CoScreen, for example, have this application to do collaborative screen sharing. So this is using the low-level API, and they've got some client-side pretty cool code that would do this thing with tagging the different windows and stuff, but it is using Jitsi underneath. So now that we know all about Jitsi, let's talk about how we're doing transcriptions at Jitsi. So for us, it all began in 2017. I want to give a shout out to Nick Fazen. He was a PhD student that interned with us, and he worked on adding the first generation of transcriptions to Jitsi Meet. This is his presentation at FOSDEM in 2018, after he had completed the project in 2017. One of my sort of proud accomplishments in life is to be quoted in his PhD. He sent me an email just a few weeks ago. I was very happy to see that he made it till the end, and he still remembered us, so I'm very proud of his accomplishments. The way we did this, it was kind of a showcase of technology. So we showed transcriptions as subtitles in real time. It could do translations because the Google Speech API, which is what we were using at the time, supported that. It wasn't like super accurate, but if you spoke English pretty well, then it did a good job. And we didn't know at the time, but it did sort of set us up for success a bit later down the line in this space. Something that we somewhat coincidentally had from the beginning was separate audio streams. We are going to actually emphasize this further down the talk, but in many instances when you need to do transcriptions, you may find yourself with a mixture of all speakers in a single audio file that may or may not have some challenges. We've got the tracks separated, which at least it means we don't need to, from the beginning, figure out a way to separate each speaker so that we don't get that mix. So our first architecture looked a little bit like this. I'm not going to go into a lot of detail of all the components, but just the Jitsi Meet client would be either the web UI or mobile app. Gcofo is our conference focus, so the one in charge of like managing the conference. Internally, Jitsi uses XMPP as signaling, and we use Prosody for that. And Gigazi is our SIP gateway, and that's what became our transcriber. This was a pragmatic decision because Jitsi was a somewhat lightweight client that could join a meeting, receive all the audio tracks, but it also had the media capabilities to transcode, for example, in order to send the call over to the SIP side. But we could take those tracks and send them to transcribers, for instance, in PCM. And then a key point as well is that the transcriber was an external entity, so we added, in a way, like it was modular, so you could talk to Google or maybe later to something else. So essentially, the client would want to start transcriptions or closed captions, subtitles. We kind of gravitated towards different terminology over time. Jitsi would request that the transcriber joins the meeting. Of course, it would all go through our signaling channel, and once Jitsi joins the meeting, it will start transcribing each participant by sending the audio to the Google Speech API in this first iteration. As the transcriptions came back, they were sent over XMPP chat and broadcast to all participants. Then later on, we would actually, in Jitsi, keep the entire transcript in addition as a kind of a single file that we could store somewhere. And to a large extent, this is the same architecture we have used today, up until we're going to talk about the different evolutions of it. But this was its inception, and it has remained this way for a long time. So maybe by happenstance, maybe because Nick was so smart, or he had smart mentors, we don't know. But we ended up in a good spot that then allowed us to experiment with more things. So we fast forward a few years. In 2020, this architecture remained the same. The feature was still a bit of a gimmick, because there wasn't much broad use of it. But some people wanted to give a try to other backends. So for example, we did get, because we had this architecture to plug the backends, then we got contributions from the community, and they added Vosk support. Vosk is this open source transcriptions engine. That's all I can say about it. We haven't actually used it ourselves, but I know some people have, so it must be useful to someone. Anybody here ever used Vosk? Yeah, that. But it's still there, it doesn't cost much to keep around. And that's, it remained like this for a few years because nothing was sort of happening to change the game. That is until 2022, when sort of the AI/LLM, spring or renaissance began. And Razvan is going to tell you more about it.
Thank you very much, Saúl. This sends the slides forward. So hello, my name is Razvan. I joined Jitsi and 8x8 around about 3 years ago, right, Saúl? And we already had this transcription set up here, but we were only using it for captions or subtitles. This is useful, I guess, maybe up to a certain point, but then with the LLMs, certain other needs came. And those needs are, yes, live captions, but also do sentiment analysis on a meeting, or, do late arrival summaries for the participants who arrive late in the meeting, or extract action points, you name it. So for that, you need accurate transcriptions. And Google at that time wasn't providing those. So, but, by chance, something else came, and that was Whisper. Whisper had a limitation. I'm going to send this back a little bit. Whisper had a limitation. One of the limitations, main ones, I would say, is that it manages to transcribe by default only like full-length audio streams, so audio files. So you just give it a file, it will do its magic inside, it will give you back transcription. We managed to override that limitation, kind of, and make it work with live transcriptions. And also because we were a little bit scared at first of sending our data, and I think all companies were at first, at least. Now, apparently, people do not fear this thing anymore as much. People were afraid to send their data over to OpenAI or Google or whatever, So we figured we might run our own LLMs and our own transcribers. So Skynet was born, which basically mashes these two features together. We have Llama on one end and Whisper, live Whisper on the other, in the same project, which is open source, by the way. You can check it out. And it runs as a modulet, so in order to, you can enable like the LLM part or the transcription part. And yeah, we were kind of happy with it. It seemed quite inexpensive at first. You could run inference both with CPU and GPUs. So we started with Llama 2, then we moved to Llama 3. And we also added some tweaks to the entire Whisper thing. I was actually using faster Whisper there, and yeah, that's pretty much it. So this was our first iteration. This is how faster Whisper works. The live Whisper implementation, very broad lines. So from Gigassi, which you already saw before, we established a WebSocket connection to our Skynet with live transcriptions enabled. And we have one WebSocket connection per meeting, so it's not like participant-based. And Gigassi transcodes the opus we get from the bridge, from the SFR, and sends like raw PCM chunks. We have an additional VAD there, which drops silent chunks and takes care of the actual timestamps of the words. This is what we use then to fill out a buffer, transform it into a file, a fake one obviously, send it out for transcription, and then sending the results back. The results are two types of transcriptions. You have like finals, which you can see here, so these do not change anymore. And then you have interim transcriptions, which are in yellow there. At one point, when we know that we have a final transcription, so it's basically a sliding window approach, we send off the final and we cut that part from the buffer. So we go ahead and transcribe the live stream like this. So this is how the captions used to look like. They work pretty well, but not that well, because these especially because you cannot only show final transcriptions, because the lag would be so they wouldn't be live anymore. They would be like, you'd see them after 1 or 2 seconds, which is definitely too much. So this line of text would jump around a lot, because the more audio you add, obviously, the more context you add, so it autocorrects itself. And it's even worse when you have like 2 or 3 people speaking at the same time. Then it's going to be a mess, and nobody will understand anything. These are a few examples. These are the late arrival summaries. So if you have live transcriptions enabled, say you joined the meeting like 10 minutes late, a private message will be sent to you. Saying stuff like, Saúl has been rambling about how Vim is superior to Emacs. That's debatable, by the way. No comments. So this is the summary. You can see in one of the products we use an 8x8, which was built on top of Jitsi. You can see like a call like history thing, where you can see the summary of the conversation, the action items, and the transcription, the full transcript. It's the meeting history. Here you can see the Brave implementation, because we also, so we can handle all this, or we could do the transcription and then communicate to our customers via webhooks each time there's a new final transcription, for example, or an interim one, and they can act on that. So they can then do the summaries and everything else. What else? So yeah, it was all fine, and it worked great. With the exception of the Whisper implementation, we also added Oracle in the mix. So now we could do transcriptions with 3 providers, our own open source Whisper, Oracle, and Google. And it worked. It was cool and all, but it was kind of expensive because you need to cater to your own GPU pool. That's gonna hurt, especially if you need to do it for many, many customers. And here you can see like a few ongoing meetings for fighting for GPU time because we had some limits. We are still using A10s, the GPUs, and for a base with the base model, so only with English only. If you go above like 10 meetings per GPU, then it's not gonna be live anymore. So you could use also the large turbo model to have like multi-language transcriptions, but you'd be even more limited to maybe 5 meetings at the same time. So it still rocks. It's still a pretty cool project. But then, you can see the challenges here. When you go at scale, so you have many meetings which need to be transcribed, then it's going to get really, really expensive. The user experience for the subtitling was not great. As I told you, they were jumping around. You cannot really do multi-language because of money, basically. We figured out that we actually don't really need real time. Because looking at the stats that we were gathering, we noticed that actually people didn't do it for the subtitles or for the late arrival summaries. They mostly did it to get some insights afterwards from the transcript. So it was a post-meeting thing. So, sorry, I do need to hurry up a bit? Okay. We decided to make it async or post-meeting. In order to do that, we asked for help from Boris. You knew him last year if you came here. He created this multi-track recorder, which was initially created for another customer of ours, but we adapted it, which basically takes the audio streams from the SFR directly and encodes all of them into a Matryoshka container. And then at the end of the meeting, it will simply upload the recording to a bucket. You can see here, it will upload the recording to a bucket and send a message to a queue. Then the async transcriber will come in, get the recording, extract the various participant streams, do the transcription, and then splice everything back together. I'm going to skip this, but I'm going to go through it real fast. So basically, we have multiple providers you can choose from. You can even do local Whisper or use OCI, AWS, you name it. And it supports like multi-language by default now. It's able to automatically guess the language. You don't need to specify it anymore because you had to specify it with the live transcription. That's pretty much it. And this is particularly useful because it's now way cheaper than actually managing the GPU fleet. You can do the transcriptions on CPU only if you really want to, because you don't really care to send it off. You can transcribe it also like 15 minutes afterwards. It's not such a big deal for some customers, it's quite flexible because you can add new transcribers, and we haven't eliminated the real-time transcriptions yet because you can run them in parallel, no problem. But now there's a new chapter, and Saúl is gonna talk to you about that.
Yes. So you can't seem to rest in this industry. So unless you've been under a rock for the past couple of weeks, OpenAI made their real-time API generally available. And it's mostly used for talking to the AI, but it also supports real-time transcription sessions. What do you know? And the interesting thing is that they had support for a transcriptions API based on Whisper, but the new real-time one, it's priced very competitively. So then, if it's the same price to do it in real time, then, after the fact, then why wouldn't I do it real time? And there's new models like GPT-4o Transcribe, It has better detection of languages if you're speaking different languages or you switch languages mid-meeting. We've seen cases where that happens. So we decided to give it a try and do serverless, I hate the term, or edge transcriber, if you will, based on Cloudflare workers. So we can even reduce the infrastructure that we've got. The idea is to use a Cloudflare worker or durable worker for rendezvous, where we would receive the one or multiple WebSocket connections with participant audio. It could either be multiplexed in one or separate. There we would create individual transcribing sessions with OpenAI, and this would be the place where we aggregate the transcription and send it somewhere. It sort of looks like this, very professional diagram here. So a key part is also we're tapping directly on the Jitsi video bridge, so we are saving ourselves a bit of infrastructure if we do it this way. We would need to decode Opus there, but there is WASM decoder, so no problem. Or you can ingest PCM directly. That would be better, because all you may need to do is upsample to 24 kilohertz and then send it over to OpenAI in this case. And so this is the prototype I've been working on last week. It is working. The jury is out as to whether this might replace our use for the async transcriber in some cases. There are still reasons why you would not want to have OpenAI transcribe your data. We do have some customers that don't want that. So the local option will always, I think it will always exist. But it is really nice that these options now exist, and we're experimenting with them to see whether they augment, replace, or pretty much augment, I think, our existing offering. And trying out Cloudflare Workers is pretty exciting, because it does help us keep our infrastructure a bit narrower. You know, as you try to do more things as a team, you need to take care of more infrastructure. Doing less of that is pretty nice. And where workers are not being used, they cost you nothing. But you do always need some servers, and scaling GPUs is not cheap. So it is a compelling argument to try and do it this way. So kind of to wrap it up, a few takeaways that I would like to share with you. The first one is that we realized probably too late in the process that subtitles are not great UX for real-time transcriptions. A side panel, however, is. This is our current implementation. You can choose what language you want to see the live transcript on. Here, if you squint, you'll see that the last message is a bit fainter. It's because it's not the final. So the previous ones are final transcripts. When a transcription becomes final, it gets updated on the spot. And, you know, people can go back and scroll, oh, what did he say? Things like that, without having to, shit, I missed the subtitle, what happened? So we think this is much better UX, and we spent far too long trying to get subtitles working. So if you're going for it, don't make the same mistake as we did. But if you want to, go for it. Pricing is key. So engineering, you know, sometimes we solve problems because we can, but not because we should. So I think in this case, pricing dominates a lot of the decisions that we need to take sometimes. So it's important to keep it in mind as you progress with your engineering. For example, when Razvan said that as we scale out, things became expensive, as an example, we wanted to actually transcribe all the meetings in the company. And for one customer, in 24 hours of a working day, we transcribed 18 days worth of audio. So shit can get expensive, and you really need to look for it. And last, of course, is that the exploration phase does not seem to be over. So, you know, don't settle and stay curious. Thanks, everybody.
Question time. Where is the microphone? Oh, I recognize who rose the hand, so let's start with the lady.
Thank you. Nice talk. It's nice to see that this kind of experience is already in the show, you know. So, no, my question is just if you have, as I can see that you have plenty of users in your system, if you have some experience of a difference in the latency or in the real-time experience with depend on the language that you are transcribing?
That's a good question. When you enable like in the first sort of implementation, right, the Google thing, you needed to specify the language, and then it would give you straight the answer in this mode. In our sort of second iteration, we could do a two-pass where you would get the transcription and then Google would translate to something. So unless the model can give you the answer straight, which is the case with the newer ones, there was a little bit more latency. But if you think about not using subtitles, right? So in the first iteration, the subtitles were actually in the right language. So while it is possible, the UX is just not good. So when we say a panel, we're talking like a couple seconds of latency. It's just that you would ideally, like if you're watching a movie, you want to see the thing as the lips move, kind of. But that's sort of, it's on the edge of what's possible. And again, it's hard to, I didn't get it, let me go back. So the panel gives you like sub 5 seconds delay. So it's definitely on that ballpark of very usable and not like a huge amount of delay with other languages.
And I think that's why we should prefer calling them captions, not subtitles, because usually subtitles are synced to the people actually talking. And sometimes they even show up before they start talking, so you have enough time to read what's going on.
Exactly.
Yeah, but your users are usually in English language, or you also have other different...
I don't think there's a difference at inference time. You were meaning inference time. There shouldn't be any difference. So if you use English, for example, it depends on so for multi-language with Whisper, you would need to use the large model, which is slower because it's huge. But yeah, I think if you would have like, I don't know, a dedicated French model, for example, you wouldn't see any difference between the...
That's the case we really have with French. Like the French are very French. They want their thing in French, right? So I've been in these meetings where they were speaking French, we were speaking English, and gotta make do.
Yeah, the multilingual have a lot of also hallucinations with the languages and mixing of that.
It depends. We've worked on removing some of them as well. So there's a lot of work done in the VAD policeman there to remove potential hallucinations.
Yeah, one thing I think we didn't mention is that like Whisper, so the Whisper OpenAI released, like they kept it, they have released some updates, but there hasn't been like a dramatic update, right? Like Whisper 1 and Whisper 3 are not like GPT 3.5 and GPT 5. The leap is not that big. But the reason why I'm excited about the prospect of using the real-time transcriber is that, well, A, OpenAI seems to have the upper hand on this one, and B, it's on their best interest for their real-time agent model to actually detect languages very well. So if they already need to solve that problem for themselves, like the transcriber would sort of get it for free. So I'm thinking that will, it may still be a problem for a little bit, but it will improve over time.
I think one thing that could be interesting to check, to test, is about the low resource languages. Beyond English, Spanish, that is the second one good in Whisper, French and those, you know, some low resource languages.
Obviously, it's not going to work as well.
No, like about the latency. If the inference of the model takes more time, you know, that the model needs thinking more to figure it out, the transcription for these kind of languages that are less trained in the system, you understand?
I see. The point for us, I think, is a bit that we need to juggle a few balls here, which is that, you know, if you want to have many small models running, that's why I started by saying, this is our frame of reference. We've got this meetings product and we cater for this type of use case. If we need to have a lot of small models and a fleet ready to spin up and down things, like it's a lot of infrastructure that needs to be managed and supported, which means suddenly your effort becomes like pretty expensive in general, versus if you think, well, for these cases, maybe I can self-host, for those other cases, maybe I can offload here. So the idea is to try and mix and match and find what kind of works. And we would also spend more time, depends on, you know, we have a very important customer, we're going to try and figure out a way to make it work. But exploration is not over, as I said. So maybe small models work in your use case, and that's great. And they would work if you deploy your own Jitsi and run them on Skynet, for example. Like that's very possible. The way we are looking at things at scale might result in us running in a slightly different way in some cases. And yeah, we're still figuring out what I'm not sure if there is one best way to do things. There will probably be a combination of for this is that, for that is that. Like maybe small models are good for some languages and real time will be good for more mainstream ones, I think.
Okay.
Thank you.
Antonio.
Okay, Antonio.
Nope.
Yeah, it works now. Thank you very much. Like, the presentation was really interesting and inspiring.
Thank you, Antonio.
Maybe just like to expand really quickly on like the last question. Last year when we were designing our own transcriber, we also had a little study done on the Whisper models. We published a preprint on Archive that's a bit outdated, but we had like some time analysis on the transcription of like some off-the-shelf datasets. And we had also offline transcriptions for datasets that were not English. And yeah, the time doesn't really change when you target different languages, especially because you can tell Whisper, hey, this is French, for example.
Thanks for that insight. I hadn't missed that you published that.
Well, anyway, yeah, everything is out there. But yeah, like my question, I think it's actually like 3 or 4 questions in one.
Okay.
Like the first one is, so you said that when you want to provide, let's say, live transcription for, let's say, customers that don't want to use third-party services, so they want to have their own Whisper, you do that on every single audio stream that you get. Sorry.
Yes.
So my question is,
Can I?
first of all, have you ever tried doing transcription of like a mixed audio stream? And in that case, have you ever tried, for example, instead of using faster Whisper, I guess you use faster Whisper, using other instances such as WhisperX, for example, that also does a diarization, I believe. So that comes for free alongside the transcription itself. Because, like...
Yeah. So thank you, Antonio, for the question. And by the way, I forgot to mention that also Antonio's solution from yesterday's presentation was kind of similar to what we did. So we can tend to arrive at the same solutions.
Great minds think alike.
Yeah. And yeah, no, we did test some solutions, and at the time, faster Whisper was the one which performed the best. And also because we do all that sliding window thing, and because we mash all the audio packages from one meeting into a single WebSocket connection, so we do keep a state inside Whisper, and we know that this packet belongs to this user, to this participant, and so on and so forth. So there's really no need to do multiple streams in one kind of thing.
Yeah, because like my point is that if you only have like one stream, ideally you have like one model per meeting instead of one model per participant.
No, actually, you have one model for everything.
Okay, so you have
So we
one model per
only load it at one. So once the pod, the container starts, it will load the model into the GPU's memory, and that's it. It stays there. It's not offloaded. It's not. It will just get used.
So it's one single model for the entire meeting.
For the entire, not for the entire meeting, for the entire instance.
For the entire instance, and then you assume that, let's say, participants would speak one at a time.
Then they don't. When they usually don't, sometimes, but most of the times they kind of wait for one another. So
Right. Okay. Yeah.
Those were the VAD and the queues that he explained in the diagram, kind of.
It's pretty accurate. Thank you.
All right, I know that there were more questions, but we are approaching the coffee break, so there will be plenty of time to continue this.
We'll be around.
Let's wrap it up with a round of applause.
thank you.
Thank you.